Okay, hi all. This video is just to explain how to factorize an expression which is in the form of the difference of two cubes. So one thing cubed minus another thing cubed. This is one example of the factors that we would have if you factorize the difference of two cubes expression. But this is also the template that we'll use in order to factorize all other difference of two cubes expressions. So if we look at this thing first, we can see that it's made up of two factors, one smaller expression, one larger expression, three terms, two terms. The first expression is just the first item here minus the second item, but with no squares or cubes or anything on it. The second expression here, second factor, which is made up of three terms, well, the first term in it is the first item over here, but instead of cubed, it's squared. Plus and always plus the first item multiplied by the second item, no cubes or squares, just a, b, and then plus again and always plus. This is the second item, except it's squared here instead of the way it's cubed from the original expression. Okay, so using this template, then we can factorize any other difference of two cubes. So for instance, if we have this difference of two cubes here, x cubed minus y cubed, if we use the same template, we know it's going to be small two-term factor multiplied by larger three-term expression or factor. We know that the first smaller one is going to have a minus in here, and then it's going to be the first item without any square or cube on it, no square or cube. And then the second one is going to be the second item here, and again without any square or cube on it. Okay, and then if we go for the second factor over here, the first term in the second factor is going to be the same as the first letter, we'll say, over here in the original expression, but again, instead of having a cube, it's going to have a square. So it's going to be x, which is the first part, squared. Then this is going to be plus and always plus, and in fact I could put in the two pluses, just copying it straight from the template. The second term, or the middle term here, is going to be, excuse me, the first item here multiplied by the second item, just like it was above. So x multiplied by y, or just xy with no squares, no cubes, nothing like that. Then the last term inside here is going to be the same as the second item, we can see from above, second item of the original expression, but it's going to be squared instead of cubed. So the second item from the original expression here is y cubed, so we'll take the y part and we'll make it squared instead of cubed, and there you have that. Those are the factors of this expression, this difference of two cubes expression. So there are some, I suppose, less straightforward ones then, something like this. If I had z cubed minus 27, well, the first thing to note is that that doesn't look like our other two, because we can see we've got a cube here, we've got the minus, same as above, but this 27 doesn't have any cube on it. So we want to make it look like this. We want this to be written as something cubed, so we can first of all change this to an equivalent expression, z cubed minus, and 27 is the same as 3 to be cubed, so 3 by 3 by 3 gives you 27, so minus 3 cubed. So now we have an equivalent expression. It has the same value as this expression, but looks a little bit different. And because it looks different, now it looks like these two, we know it looks like a difference of two cubes expression, we can factorize it in the same way. And so using our template above here again, we know that the factors are going to be one of these two item factors multiplied by one of these three term factors. And we know in the first one, it's going to be the first item, take the second item with no squares or cubes. So here, first item is z, minus the second item is 3, and no squares or cubes. Then over here, look, we can put in the plus, and the plus, we know that's going to be going in. The first item here is going to be the first item in our original, except squared rather than cubed. So first item in our original was z, squared rather than cubed. The middle part are these two items multiplied together, so it's a z and a 3. If I multiply them together, I could say z3, but more usually in mathematics we put the number first, 3 multiplied by z, which is 3z. And lastly then, we know the last part of the bigger bracket, I suppose the 3-term expression, is the last item from the original to be squared though instead of cubed. So the last item over here is 3 to be squared instead of cubed. Now, rather than leave it like this, we might just do one last little bit of tidying up. So z minus 3 times z squared plus 3z, and then instead of leaving this as 3 squared, because we can square 3, we know it's 3 multiplied by 3, which is 9. And now we've got our factors of this, which is equivalent to this. So the factors of this, which means they are the factors of this also.